So one thing that students have found helpful with density is this density triangle. I don't know if you've seen this. This triangle is wonderful as long as you set it up correctly. So I've had students who are so excited about the triangle and then they say, oh, I filled it in wrong. If you fill it in wrong, you get everything wrong about density. So remember that density is mass over volume. Where do you go to get your driver's license renewed? DMV, right? So think of it that way. You can always set up density problems as conversions, like what we've been going through. But if you sometimes get tripped up with setting it up that way, you can use the triangle method. With the triangle method, whatever you're solving for, whatever you're asked for, you cover up, and then you say you're solving for D. D is equal to M over V. Well, let's say you're asked to solve for mass. So you cover up the M. Mass is density times volume. Now, my high school chemistry teacher, who got me so interested in chemistry, she would always say, mass is equal to venereal disease, VD, because she set it up, so that's how I've always remembered it, and it was a good, whatever it takes to remember.
Not Valentine's Day.
No, right. Not Valentine's Day, right. You gotta make it memorable. She's what?
I just can't believe she used that.
I know, it was in high school, too.
It kicks for a lot of people when you make it something like real silly or stupid or something.
Right. Yeah, and that's why I always say that, because it's like, whatever it takes to remember it. But so if you're asked to solve for volume, you cover up V, and it's M over D. The nice thing about this density triangle, if you're really weak on algebraic manipulations, you don't have to do that. But I caution you, I had one student who was so earnest and sweet, and she was so proud of her triangle. And then when she put it on the exam, she put it backwards. And so everything came out wrong. If you work the conversion factor method, as long as you have everything set up and you get the units to cancel out, you're going to be good. So with that said, I want you to go through and work problems 1, 2, and 3. So either using the conversion method or the triangle method.
That's a lot easier.
So number 1, using the triangle works pretty nicely, right? Just plugging and chugging. So D equals M over V. Your mass is 36.4 grams. Your volume is 45.6 milliliters. So you're just going to divide on your calculator, and of course pay attention to sig figs. Even though you want to forget them for a while, take a break. We'll get a break, by the way, from sig figs in units 3 and 4 and 6, so you don't have to think about it. No. How many sig figs should we have in this answer? Good. So it comes out to be 0.798. What are the units on this? Grams per milliliter. Good. Number 2, you are given the density, you're given the volume, you're asked to solve for mass. So if you use the triangle, then mass equals density times volume. It helps. I have a lot of students who, when they use this density triangle, they just write out the slash and hope that all the units work out in the end just magically. They don't actually cross. And so if it's written slash milliliter, like this density is, write it over 1. So that way you can convince yourself that you're going about this problem the right way. So the volume, 18.0 milliliters. Milliliters cancel. How many sig figs will we have? 0.67 times 18. So you end up with 2 sig figs, 12 grams. Now the last problem, I gave you the density. I gave you the mass. I want to know how many milliliters there are. So I'm looking for volume. So a lot of you might have said, okay, well, I'll use the density triangle. Volume equals mass over density. And I'm just going to plug and chug. So where this density triangle kind of can get tricky is when you're dividing fractions by fractions, because when you divide by a fraction, you're actually multiplying by the reciprocal. Remember that? So it gets tricky. So if you put the mass over this, 25 milligrams divided by 1.03 grams per milliliter, you're thinking, I hope these units work themselves out in the end, because I have no idea what units I'm going to come up with. And this is definitely a case where working the conversion way might be beneficial, because you can say, oh, I need to convert milligrams to grams, and then I can convert grams to milliliters. That makes sense. So right now, this density triangle is not going to work out, because I have units of milligrams and I have units of grams. They're not going to cancel. So I know a lot of you will use this density triangle, but this is an area where I caution you. If you don't have the exact units that match up, grams, grams, then it can get tricky. So I'll show you this problem working the conversion factor method. If you work the conversion factor method, the quantity with 1 unit is your starting quantity. So this is your starting quantity. I'll put SQ by it. So 25 milligrams over 1. So we're starting in milligrams. We want to get to milliliters, but we cannot use the density directly to get milligrams to milliliters. So we have to convert milligrams to grams, grams to milliliters. So in 1 gram, I have 1,000 milligrams, and I got that conversion factor from my prefix ladder. Once you start doing these problems over and over again, you will get to this point where you can quickly say, well, I know 1 gram has 1,000 milligrams. It may seem like there's no way you'll ever have that, but you will get to that point. So milligrams cancels. Now I can use my density, and I'll put density on the bottom. Grams cancels here. So I'm actually doing the same operation.
Thank you. I don't know how I did it, so thank you. If it happens again, just play. Thank you very
That's
much.
what I was saying. So we're actually doing the same operation, but we had to divide by 1,000. So if you wanted to use the density triangle, as long as you converted the milligrams to grams ahead of time and you had grams over the density, it would work out great. So 25 divided by 1,000 divided by 1.03. How many significant figures should I have in my answer? 2. So I'll end up with 0.024. Yeah, because I don't have any. 2 is the first digit that I drop. Any questions on that one?
So if we, like, for purposes on the exam, like you said, because you get partial when you show work. So, like, I did it where, like how you said, where you just converted milligrams to grams first.
Mm-hmm.
So you can kind of just do that step first. And then
Right. So if you move the decimal and then did the density triangle, that's great. And I can follow along with it. That's fine. Another question?
Didn't you say that density is exact?
Density is not exact
Okay.
because it's a measured quantity. Because remember, density is mass over volume. So you measure the mass, you measure the volume. So because it comes from two measured numbers, it itself is considered measured. So because it's measured, you have to look at density for significant figures as well. So you've reached a new level where not only are you looking at the starting quantity, but you're also looking at the density. So you're looking at this for sig figs.
Okay.
So good question. Other questions? All right, so we're going to move on to specific gravity. And remember, we measured specific gravity in lab. And for our purposes in class, specific gravity and density are pretty much the same. We consider them the same. So I give you a definition here. Specific gravity is the density of a substance divided by the density of water at the same temperature. Pretty much everything we do in this course is room temperature, 25 degrees Celsius. The density of substances changes with different temperatures. So your specific gravity could be different. But we don't get into it. You know, other chemistry courses, you might delve deeper. We don't have time because we have all these different chemistry topics to cover. So specific gravity is the density of a substance divided by the density of water at the same temperature. So I'm going to write specific gravity is equal to the density of a substance over the density of water. Density of H2O. Now both these densities are at the same temperature, but like I said, we're pretty much always doing things at room temperature. So specific gravity ends up coming out, if you have units of density, let's say your substance is alcohol, we'll have units of grams per milliliter, and then the units of the density of water would be grams per milliliter. My units will cancel. So what are the units on specific gravity? There are none. So this is, like I said in lab, one case where I will not take off points if you don't have units on your specific gravity. If you do have units on specific gravity, then I'll take off points. So you've just got to be making sure of what you're doing. Remember that we looked at a hydrometer in lab to measure the specific gravity. They're used, like I said, winemaking, medicine, saltwater aquarium, making your beer. I'll give you this example. Grape juice, which is what you make wine from, has 20% dissolved sugar. The density I had this as specific gravity. So the specific gravity of grape juice is 1.082. Dry wine, which has an alcohol content of 12%, has a specific gravity of 0.984. So having a hydrometer to measure the specific gravity of your barrel, of your vat of grape juice, is very useful because there's a difference, and you can tell how much more fermentation needs to take place. Like I said, the salinity of your saltwater aquarium, you need to add more salt, add more water. You can use a hydrometer. So I've had students who, when we talk about hydrometers, that's what I use for my saltwater aquarium. They get so excited about that. So It was very useful, even though when we were in lab, looking at the hydrometer was kind of a little crazy. So
is there any kind of like digital form of that, or is it just like what was on the lab?
if you have the glass version, a lot of times you would take a sample and then use the hydrometers that we saw. Most everyone in medicine is using strips. So a lot of times strips can be used.
I've worked as a pharmacy tech, and we use like when we did compounding, which is huge now, where like because a lot of drugs are resistant for people, they like you measure like let's say your powder or whatever you crush up, and then like your suspension that you're going to dilute it with, it's like you kind of do a quick calculation, plug it in there digitally, and then it just like starts shooting it out.
Mm-hmm.
It's crazy.
So this is to dispense a powdered substance?
To like make like a certain like antibiotic or like a cough syrup, like maybe make it more, you have more concentrate or whatnot. And
so it's more
it'll
dilution.
Use this to do it automatically. To where you used to have to like measure every single thing.
Yeah, it is amazing what they have now. In terms of what we're going to see for problems involving specific gravity, a lot of students are thrown off because their units are not there on specific gravity. So, like this problem, the specific gravity of chloroform is 1.4832. What is the mass of 5.6 mils of chloroform? Really, specific gravity is density without units. So you can very quickly convert it back to density if you just put the units on it. So we have units of milliliters here. So it would be really handy if our density was in units of milliliters. So we'll say the density of chloroform is 1.4832 grams per milliliter. So whenever you see a problem involving specific gravity, and it's asking for either mass or volume, just go ahead and convert it back to density. Now, your pre-lab for experiment 3 had a lot of questions involving specific gravity, and there were some questions at the end. So now you can work these questions. So if you want to, you can go ahead and do the density triangle, or you can do the conversion method. Either way, you will come up with the same answer. You'll be doing the same mathematical process. I'll do it both ways. 5.6 milliliters over 1. In order to get milliliters to cancel out, would I multiply by this conversion factor? Or divide by it? Would I flip it or leave it as is? Leave it as is. Good. 1.4832 grams. 1 milliliter. That cancels out. 1.6 times 1.4832. Now, how many significant figures would I record? 2. So it would just be 8.3. And what are the units on that? Grams. Now, if you did it the density triangle method, you're looking for mass. So you're looking for M. So remember, make sure you have the right triangle. Then D and V. So mass equals density times volume. Bless you. And then the volume is 5.6 milliliters. So you're doing the same thing. You're multiplying. Any questions on that? So work your pre-lab for experiment 3. Work through the questions on experiment 3 because there are some good review points on this. Like I say, a lot of times students will say, specific gravity is not, I don't understand specific gravity. And you make it harder than it needs to be.
So is the only, like, kind of what we did in lab, like, for those of us learning in nursing, like, is it the only real way that we would, like, do it on the job would be kind of those strips that we use?
The strips, yes. Unless something were happen to the strips, then you had to go back to the old way. But I think the strips have been used for some time now. So. All right, so we're going to move on. By far, the most challenging thing in the chapter 1, first thing we covered, is the conversion factor. So I want to stress that if you're having trouble with conversion, keep practicing, keep hammering away at it. The more you practice, the easier it will become. And you can do the same practice problems over and over again. I was always amazed when I would rework chemistry problems how I didn't remember them. And that was always troubling, you know. But if I got to the point where I was doing my homework often enough that I did remember them, okay, I'm more likely to do well on the quiz or the exam. So we're going to shift gears. We're going to start learning the atoms and the elements. And you have already looked over the pink and yellow flashcards and memorized those. We had that quiz. So I know a lot of you worked very hard on that. I have some common confusing elements listed. And also I wanted to point out how capitalization is very important when you're talking about elements on the periodic table. From this point on, we're going to be using our periodic table a lot more. It will be hard to do your homework without a periodic table. So I always laugh because in our house, in our office, like all these different places, I have periodic tables stashed because depending on where I'm doing my grading, I need a periodic table. So it might be that you get to be the same way. So there is a difference between CO, capital CO, lowercase co. This is carbon monoxide. You hear about the carbon monoxide detectors in your house, which are very important. We're going to learn how to name these compounds in Unit 2. So we're not getting into formulas just yet, but we will. If you didn't capitalize the second letter, this is an element. Does anybody know what element this is? Very good, cobalt. These elements, when they're in their pure form, it's very easy to confuse the symbols. What's K? Potassium. What's P? Phosphorus. Very good. What is Na? Sodium. What's S? Sulfur. Good. So I saw a lot of confusion on S, either sodium or sulfur mixed up. So just be careful with that. Mg, Hg, and Ag. Mg, does anybody know what it is? Magnesium. Hg, mercury. Good. Ag, silver. So we know magnesium here. What about Mn? Manganese. Yes. Ba, it's barium. B, boron, very good. Br, bromine. Fe, iron. F, fluorine. How do you spell fluorine? F-L-U-O-R. Good. So we know K is potassium. PT is platinum. Fe, iron. Ferrum, that's where it comes from. And then I is iodine. Whenever I see I think of iodine. One of my friends in graduate school, she was from Nigeria. She would always say iodine. So, give her. All right, what are the symbols for fluorine, chlorine, and bromine? F, Cl, Br. Go. So now, having your periodic table handy will be very helpful for this section. I always, no matter how many times I say this, I will always get questions. Do we have to memorize the periodic table? No, no, no. You do not have to memorize the periodic table. The periodic table that will be given to you on exams and quizzes is the one that I gave you the first day of classes. So there are two sides to this periodic table. There's the front side, which has a lot of it. This is the side that we're going to be using for this unit. On the back side, kind of looks crazy. We will not be using this side until Unit 2, and we'll only be using it for a little bit. So if you want to write on your periodic table, this side for Unit 1. And then we'll write on the other side when we get to it in Unit 2. But you don't want to have anything to do with this crazy side right now. So everything will come out wrong. You'll get crazy numbers and you'll think, oh my gosh, this is should be so much easier than conversion. Why am I not getting it? Most likely because you're looking at the wrong side of the periodic table. So that's why I always point out to students, use this side for Unit 1. So one of our objectives is to use the periodic table to identify the group and the period of an element and whether it's a metal or non-metal. Be able to indicate on the periodic table the appropriate families, groups, periods, or sections, which are referred to by the following names. Alkali, metals, it goes through. It seems like an intimidating list, but you will know this very quickly. This is kind of a rough outline of the periodic table here. You will find 3 groups, metals, nonmetals, and metalloids, and we're kind of addressing each one of these entries in the objective. Metals, by and large, are on the left side of the periodic table. So they're on the left side of the periodic table. They are solid at room temperature. The exception is mercury. Metals are good conductors. And we're not talking about musical conductors. We're talking about conductors of electricity, right? So they're good conductors. They're malleable. Can be hammered into sheets. And a lot of times, they're lustrous after being cut. So they're lustrous after cutting. So there are some metals that when you work with them in the lab, they're very dull, and then you cut it and it's very shiny. That's where it's reactive. There's a lot of oxidation that takes place at the surface of these metals. So on this rough periodic table, you have your main group metals. Maybe we'll help with that. So these are your main group metals. Then in between, you have transition metals. So I'll do transition metals. Horizontal stripes. Transition metals. And on your periodic table, not on this example that I have on page 19, you'll see there is another block at the bottom. These are inner transition metals. And so they actually, if you look at the numbers, it goes 56, 57, 58, 88, 89, 90. So they kind of fit in right here. So these are the inner transition metals. I'll write this over here. So those are the inner transition metals. So all of these that we've just labeled would be classified as metals. And so even though I said, metals can be found on the left of the periodic table, it's more like the left and the middle of the periodic table. So if you want to add left and middle. So nonmetals can be found on the right of your periodic table. Nonmetals are poor conductors. So they're poor conductors. And you can find examples of nonmetals that are gases, liquids, and solids. So you get so gas, liquid, or solid. Whereas with the metals, you found more solids. So I will do the nonmetals. Polka dots. My daughter loves the combination of stripes and polka dots. She can get an outfit that has both. She is happy. Now, it's hard to tell from the way this copy came out, but this at the very top, the first element, hydrogen, is a non-metal. So this will become important later on when we go through what type of bonding, the classification of metals and nonmetals. So this in-between area is called the metalloids. You'll hear it, the term has changed a lot. It's semi-metals or semiconductors. So semi-metals or semiconductors. Sorry about that. Semi-metals or semiconductors. They have properties between metals and non-metals. So I'll just leave this one the way it is. So this is something you need to know, the different properties. And we're going to go more specifically into the groups on the periodic table. So if you go to the next page, groups in the periodic table are vertical. Periods are horizontal. So groups are vertical, while periods are horizontal. So the periods are numbered. We have read 1, 2, 3, 4, 5, 6, 7. As are the groups. So the groups, if you look at the periodic table that I've given you, you see a lot of different numbers above. At the very top it says group 1/1A, group 2/2A. The way we actually have you number is not quite exactly like this periodic table. And I'll write it on this so it's clearer. This is group 1. This is group 2. Skip over the transition metals. I think the way the front of the in your textbook, the front of your periodic table and the front cover, that's the numbering we prefer. It can get kind of crazy and confusing, so we try to keep it as simple as possible. So skip over the transition metals and then go 3, 4, 5, 6, 7, 8. Numbering the periodic table this way, the way we have the groups numbered, is very useful when it comes to talking about ions and ion charges, and which is Unit 2, but it kind of sets the stage for you, so you're familiar with that. Now, these, we have lots of groups or families, and you can kind of think of these as, it's almost like your last name. So alkaline earth metals is group 2. Oh, and by the way, all of these that I just numbered, these are considered, so groups 1 through 8 are considered main group elements. And the non-main group element would be your transition metals. So non-main group and your inner transition metals. So this is non-main group. Okay, so halogens are group 7. Noble gases are group 8. Alkali metals group 1. Main group, just went through pretty much groups 1 through 8, no transition. Transition metals, you'll see transition metals were the ones I labeled, so it's kind of the in-between. Sometimes you'll see it labeled as the B group. The inner transition metals, the first period within that is called the lanthanides, and the second period is called the actinides. So lanthanides, actinides. Let me spell it. So the lanthanides are here, the actinides are here. So to get an idea of where these different groups, these families are, I recommend filling that in. So you can go ahead and fill that in now.